Hello. We're going to explore in this video this week the sorts of notes that it is a good idea for you to take for this week. So we mentioned in science classes that an option for note taking, we're not going to spend a lot of time writing on the board because people learn in a different way, but at some point you will need to keep a record of what we've done. For some of you, you'll just be able to do that as we explain things. For some of you, this video each week is going to be really valuable because you're getting our thinking about the most important things and how to organise it in your book. So if it's helpful to you, please watch this video. If you've got another way of keeping up, that's absolutely fine too, and this video won't be as useful for you. Okay, let's start the process off by the first thing we need to look at this week. So we'll pop up a heading for the disciplines of science, or the areas of science. We might call it disciplines and use that word to start off with, disciplines of science. And we need to know about those. We've covered them in class. The first discipline we had a look at was chemistry, and that's what we're going to look at first term. And chemistry is stuff, which is basically everything that makes up the world and how it interacts. That makes up the universe. And how it reacts. Can probably recall last year some reaction. By the way, that is REACTS. It didn't appear. It looks more like a E, but it's actually meant to be a C there. Second item we had a look at after chemistry was geology, which is basically the Earth. The earth and rocks. Just to remind yourself, so chemistry is stuff, geology is the earth and rocks. Clearly chemistry is important to explain geology, but geology goes through how the earth formed and how there's still activity on the surface of the earth and underneath, and all about rocks, which are really important because we get important minerals out of rocks and metals that are really the foundation of all the modern materials that you use in the world. After geology we get to biology, which is basically to do with living organisms. So the key living organisms that people first think of, which I'll put in brackets, or after the EG, is animals and plants. But they aren't the only ones, and we'll learn about a whole heap of different types of living organisms that you wouldn't say is an animal or a plant, and I think you'll find that quite interesting in term 3 when we do that. And at the end, the final area is physics, which is about forces, motion, light and sound, and electricity and magnetism. About the forces really that make up the world. So if chemistry is about stuff, physics is about forces. Forces, motion, energy, light, sound, electricity, and I'll just make this whole page slightly smaller so I can, whoops, I seem to be rotating it as well, didn't mean to do that, so I can just fit in the word magnetism down there. So that's the first thing I'll be writing in your book. I apologise slightly. It is actually quite difficult to write with this little stylus pen, and my writing is probably a bit clearer on the board, but I'm trying my best to write neatly with this. So that's the first thing I'll be writing. By the way, there's a spelling mistake. Disciplines needs an I in, so please go back and fix it up. I'll just pop that in now. Disciplines with an I. Disciplines. My apologies for that spelling error. So when you've finished writing that in your book, then you can continue on. So you'll need to press pause now. So you've got an opportunity to write that down, because I'm going to go on straight away. Okay, you've pressed pause. Now you've pressed play again, and we are on to the next bit. On to the next bit, we need to look at safety. Safety is fairly clearly the sorts of things we wrote on the board. Now, we might have written slightly different things on the board from what I'm going to write down here, but here is the list that I think is probably the most important list. There may be extra things written on the board, but these are the most important things. Listen to instructions, because we will explain how to use things safely, and there's lots of things you won't know how to use until we explain them. And along with listening to instructions, make sure that you don't use things that you don't know how to use. So if there's things lying around the room that look interesting, don't touch them. We'll explain how to use them when we're ready to use them. Wear safety glasses, and there's other safety equipment that you'll need to wear from time to time as well, but the safety glasses are the key one. We've got lab coats also for certain situations when you wouldn't want to spill what you're using on you. Smell cautiously. In other words, you'll probably have seen us do it ourselves as teachers when we demonstrated it. You don't go and stick your nose in something and then breathe in a lot of stuff. Don't eat or drink. And our last rule is tell the teacher if something is broken. When there's other specific things, we'll run into them. For example, if you're handling chemicals, we'll say how to safely wash a chemical off if you get it on your hands, or if you need to use gloves. We'll explain all of that for you. Teacher could have been spelled a bit better. It is Teacher, and that's meant to be an if. So I apologise if my writing isn't as good as you. I'll see if I can find a better stylus, buy a thinner stylus, make my life a bit easier to write. Okay. Remember to pause this so you can get this written down before we start on the next section. Okay, we're up to the last key thing that we had a look at this week, and that last key thing that we had a look at was all about the scientific method. And if we remember the scientific method, it was the key thing about the logical way we think as scientists. So a scientist has an idea and they want to go and prove their idea. That's a D, by the way. I'll see if I can write that a bit better. Don't know whether I made it better or worse. Okay, the first thing scientists do is they have an idea about how something might be in the world, possibly through earlier observations or just generally their idea. So they start with their idea about the world. So that's the first step. Start with idea about the world. Going to pop that in a little box to show that's the first item. On the kind of chart I'm drawing here is what we call a flow chart. You'll see them quite a bit as you go through high school. Then we do our research. So we do some background research, first of all, to find out, has anyone else had this idea as well? As we mentioned, this is a step that we might miss out on deliberately as part of your science, because quite a lot of the things that we're obviously exploring are things that people have explored previously, but for you it's brand new, even though for other people it's not brand new. Okay. Then we make a prediction, which we call a hypothesis. So we make a prediction. That's our next step. Pop this in now. And alongside we might write in the word hypothesis, just to remind us. Hypothesis. If you're curious, if you've got more than one hypothesis, people don't say hypotheses, they actually say hypotheses, so it becomes hypotheses when it's more than one, when it's in the plural. Okay, after our hypothesis, we design the experiment and we carry it out. So we might go and pop these next steps in. To make it easier, I'll just make the whole thing a bit smaller. Let me go and do that, and then I'll be able to put the other stuff and you'll see it all on the one page, which will make it easier for you to draw in. So I'll just make the whole page smaller. Whoops. I want to zoom out. Don't want to, and I'll move that up, and we should be able to get the whole thing fit on the page next. So the next thing we do is we design the experiment. Then we carry out the experiment, and after carrying out the experiment we analyse the data. So, go to analyse the data now. Now often we call the data a different word, we call it the results. So I'll go and write that alongside. So we might use a couple of different words. Rather than calling it data like I'm doing there, we might actually call it results, or sometimes people just call it the measurements. And then after carrying out the experiment, let's go and make this a little bit smaller once again. We then, whoops, this is interesting. I might just move it up instead. Probably because I'm not clicking on the zoom in and zoom out thing. There we go. And then finally, we ask the question, was the prediction correct? Remember, another word for prediction is hypothesis. Oops, wrong colour, sorry about that, change colour. Question, and if it's a no, we'll change our hypothesis and redesign the experiment again. So we'll go back to the beginning. You might need to redesign the whole experiment. It might be redesigning a little bit of it. Depends what the situation is. We're going to pop that in the box here. Redesign experiment. Hopefully I can get the whole word written in experiment. And then we'll go, and we need to change the hypothesis. Full stop there, full stop there. So there we go. And if it's the other way around, if we're a yes, then we've basically got to the end. We're finished. So going a little bit further down, I should be able to move everything up now. Go. We can say finished on the bottom. And then finally, we had a look at fair testing, but I'll give you an opportunity to write this down, press pause when you're finished, then you can restart. Just before doing that, I might make it easier for you by just seeing whether I can zoom out the whole thing, so you can see the whole thing in one go. Is that better? Oops, things are moving around. It's a bit unpredictable, this thing. Don't know whether I've made your life easier or harder. You can see the whole thing on one page now. And finally, in your notes, we'll have a look at fair testing. So for fair testing, our key ideas where we had an independent variable, which was what was being changed. For instance, you want to work out, do cars with a certain colour heat up more quickly than other cars? For example, do white cars heat up more quickly than black cars, or vice versa? Then what you're changing would be the colour of the car. The dependent, so that's our independent variable. The dependent variable is what's being measured. So what you'd be measuring is the temperature. You'd probably be measuring the temperature after 1 minute, and then the temperature after 2 minutes, etc., and seeing whether the temperature goes up inside the car. What is being measured as a result of the change, if you're being really accurate. And then finally, we had the idea of keep everything the same except for the independent variable. So this is, I'm going to put in bold, keep everything the same except for the independent variable. Another important point I'll put down the bottom is repeat the experiment several times. In case something or a measurement is inaccurate the first time. then hopefully if you get lots of data, then you'll be okay. You'll discover that that one particular data point doesn't make sense with the other ones and realise that that wasn't a correct data point. Okay, that's what I think are the key ideas that we need to be writing down in our books for those of you that are learning through that method. I hope that's been of help to you, and we'll do something similar and make a similar video next week for you. Thank you.